So this is the final section for chapter 3, 3.5. And we are going to combine everything we've done from these other sections to create what's called the 5-number summary, and then the visual representation of those quartiles, that 5-number summary in a box plot. So to get started, we need to know what the 5 values are in a 5-number summary. So the 5-number summary of a set of data consists of the smallest value, the Q1, the median, the Q3, and then the largest data value. So we will always write them in numeric order, starting with the minimum, then Q1, then median, then Q3, and maximum. All of these we could find by hand, and we could also find them by Statcrunch. And we have found all of them already. So this is now just kind of putting it all together. All right, so the data in the table below shows the finishing time in minutes of the men in a 60 to 64-year-old age group in a 5K race. Determine the 5-number summary of the data. Okay, so before I can do anything, we would either have to arrange the data in order, or I could go and type all of this into Statcrunch. This is the data in ascending order. So if I wanted to do it by hand, I could work my way through here. You'll see that this is the minimum, which is right here. Here's the maximum, which is repeated here. I could work my way to the middle value. There are 21 values. So number 11 is going to be in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's your median. And then I could find the Q1 and Q3 by hand as well. All right. I don't have to because it does give me all of it here. It's going to give me all my information here. It is not going to tell me, though, if I have what my lower and upper fence are. That is something that I would have to calculate by hand. So before we can draw our box plot, we do have to double check our upper and lower fences. So we need to determine the lower and upper fences, remembering we do these two formulas, Q1 minus 1.5 times IQR, and Q3 plus 1.5 times IQR. All right, so if I did that here, Q1 26.06 minus 1.5 times the interquartile range. So we got to figure that out. Minus 1.5 times interquartile range. Let me write down what Q3 is. 37.24. Let's see. Q3, 37.24 minus 26.06. That's going to give me my IQR. 37.24 minus 26.06 is 11.18. All right, so 26.06 minus 1.5 times 11.18. As long as you have a scientific calculator, you can type it in exactly as you see that there. So 9.29 is my lower fence. My minimum is above that, so I'm good there. We're going to check the upper fence, 37.24 plus 1.5 times 11.18. The highest value is 54.01. Our high maximum is above that. So this value here is actually an outlier. After you determine your upper and lower fences, you're going to draw a number line long enough to include all of the values. You're then going to put a vertical line at Q1, M, and Q3, enclose the vertical lines in a box, and then we will label the upper and lower fences. We can draw a line from Q1 to the smallest data value that we have that is larger than the lower fence, and then draw a line from Q3 to the largest data value that is smaller than the upper fence. These lines are called whiskers. All right, so let me give you an idea here. Our smallest value was 19.95. So I'm going to go 19.55. So I would make a number line. Maybe I would go by 5. Let's count by 15. or start at 15, kind by 5. So 15, 20, 25, 30, 35, 40, 45, 50, 55. That would encompass everything on my number line. Okay. Insert vertical lines at the Q1, the median, and the Q3. So I would put a vertical on 26.06, 37.24, and what's my median? 30.95. Enclose those in a box. So they make a box. All right, so label the lower and upper fences would be next. So 9, oops, I guess we technically, the lower fence is below here, it's outside there. And 54.01 is there. So lower fence, upper fence. All right, draw a line from Q1 to the smallest data value that is larger than the lowest fence. So this value, the lowest value we had is within our fence. So we're going to draw to that. 19.95 dot, and I'm going to draw to it. Okay, on the other side, our maximum is outside of the upper fence. So draw a line from Q3 to the largest data value that is smaller than the upper fence. So this data value is an outlier. So this is the one I'm going to draw to, 49.17. Okay, any data value less than the lower fence or greater than the upper fence is marked with an asterisk. So the highest value we have is 54.63. And because that's above the upper fence, it is going to be marked outside with an asterisk. Okay, again, you are not going to have to do this by hand. I am showing you it here, but Statcrunch is going to do all of it for you. Okay, so the next slides here are the steps that explain exactly what we just did there. So this is what your graph is going to look like from Statcrunch. It's going to put all of those other steps all together. So I can look here. Here's my min. Here's my Q1. Here's my median. Here's my Q3. This value is my maximum, but it is an outlier. Okay. So that is what we're going to do here, creating that visual. So I'm going to do 2 examples, and then we'll discuss a little bit about their shape. Okay, so this is the same travel time data. I don't think I have mine saved anymore. So I am going to open a new Statcrunch here. Give me just a second. Hopefully by now you guys are comfortable with getting to Statcrunch on your own. All right, so we had 23, 36, 23, 18, 5, 26, and 43. So to remember, if we want to get that 5-number summary, we go to Summary Stats columns. We select our variable and compute. So they're in a little bit different order here. Minimum 5, Q1 18, median 23, Q3 36, max is 43. It's going to give me all the calculations here, but I don't know right now if I have any outliers. Okay, when I create the box plot inside of Statcrunch, it will calculate that automatically for you. So if I go to Boxplot and I select my variable, I like to draw mine horizontally. So I'm going to do that. And I want to leave this, use fences to identify outliers. We want to leave that on. And as long as it is not an outlier, you will have a graph that looks like this. I will try to show you one here with an outlier just to show you the difference. do this one. 3R3, that's the one we're going to work with. All right, so these are ages of different justices. I'm not sure where they're from, but we've got ages of 17 different justices. So if I want to find my 5-number summary, I go to Stat, Summary, Stats, Columns, select my column, and I'm going to have my values here. So my 5-number summary in order: 44, 55, 58, 62, and the maximum is 69. Okay, that would be my 5-number summary. Those are the values that would be used to make your box plot, as long as none of them are outliers. Okay, so if we wanted to calculate upper and lower fence here, we could do that really quick. So the upper fence is Q3 plus 1.5 times IQR. Okay, so Q3 is 62, add 1.5 times the interquartile range. So let's see, Q1 to Q3, 55 to 62 is a difference of 7. And if we do that, 62 plus 1.5 times 7, because 72.5. And everybody is below that, so we're good. So my lower fence is Q1 minus 1.5 times IQR. My lower Q1, 55 minus 1.5 times that same. That's supposed to be a minus sign, not a sign. Oh my goodness, I'm hitting the wrong buttons. Sorry. 55 minus 1.5 times 7 is 44.5. And I have a value 44. That is smaller than my lower fence. So this is going to be an outlier. And I'm going to see that on my graph. Okay, so if I go to a box plot here, I select my age. And again, I always like to draw mine horizontally. I'm going to click compute. And then you can see here, this is the lowest data value that I have that is within the range. So 46 here, it says if I hover over the lower limit is 46. That's the lowest value within normal range. But I have this value out here, which is an outlier of age 44. So Statcrunch will automatically determine those for you as long as you leave that default setting on here of using fences to identify outliers. It does calculate all that for you, but it does not calculate what the actual upper and lower fence values are. That is something you would have to calculate. Okay, so why do we do this? What do these tell us? Well, they just give a very good representation of the spread of data for each quarter here. So in a normal shape distribution, your box plot is going to be very symmetric. That's this middle one here. Okay, you want to have symmetry. It's 2 boxes to be the same general width, and then you want to have about the same length of whiskers. In skewed data, one way or the other, you're going to see that one of the boxes is slightly larger than the other, as well as that tail on that side with the larger box is also longer. So this box is longer, this tail is longer. I have skewed to the right. In this box plot, the left box is bigger and the left whisker is bigger, so we are skewed left. This data is more spread here than it is on this other side. So our goal is always to have symmetric symmetry, because symmetry implies normal, implies that our data is normal and that it is evenly spread between the different groups. Okay, so just a way to kind of connect all of the things that we've done together here in chapter 3. And I hope that it makes sense. If there's anything you need extra help with, please do not hesitate to email me, ask a question, or post it for the discussion board. I will otherwise see you in chapter 4.